Okay, I want a script for a podcast about DeepMind for people who are curious about artificial intelligence. It's presented by Hannah Fry. Complete text. Okay, here we are. Welcome to the wonder of AI. I'm Hannah Fry, I'm a mathematician and the presenter of this podcast. Today we're going to be talking about how AI is used to make computers understand the words we're saying to them. So, why don't we start by asking ourselves a question? How can we use AI to do things better? This is episode 2 of the DeepMind podcast, Speaking of Intelligence. You might have guessed already that I didn't write that introduction. It was actually written by a machine, specifically a large language model, which uses deep learning to generate human-like text. And it was good enough to be passable, although I'm not sure yet if that says more about my scriptwriting abilities or how good the algorithms have become. It's certainly true, however, that when the best-known large language model, called GPT-3, was released by the company OpenAI, it demonstrated an ability to generate news articles, conversations, and stories that were almost indistinguishable from those written by humans. Simpler versions of these language models can also be seen everywhere in our daily lives. Every time your text or email software auto-completes
a sentence for you,
or you interact with a chatbot, or translate text from one language to another, chances are there's a language model behind it. And there's a good reason why language models are causing such a wave of excitement at DeepMind in particular. Not just because better models will be able to write better scripts, but because some researchers here think that language itself will play a pivotal role in getting to artificial general intelligence, or AGI. We talked quite a bit about AGI in the first series of this podcast, and particularly about a paper from 2007 written by Shane Legg, one of DeepMind's co-founders. In it, he tried to pin down exactly what is meant by intelligence, and here is the definition that he settled on.
Intelligence is an ability to succeed in some very wide range of problems and situations, environments, and so on.
For Shane, the advantages of building an artificial general intelligence that could demonstrate such versatility are clear.
It's a system which is able to learn to be very good at many things. That's almost the definition of useful. It could be used to advance science and arts and literature and explore the universe and do all sorts of wonderful things if you had really powerful intelligence.
For reasons we'll come to in a moment, instilling AI with a capacity for language seems like a promising pathway towards AGI. But well before the notion of artificial general intelligence became mainstream, AI researchers have been trying to create machines that could hold a conversation. One famous early attempt was a program called Eliza, built in 1964 by the German computer scientist Joseph Weizenbaum. Eliza's purpose was to act like a psychotherapist. You would write into a keyboard about something that was troubling you, and Eliza would respond with a series of stock answers, like, "Can you elaborate on that?" or occasionally echoing your words back in the form of a question. It was such a simple algorithm, but to everyone's surprise, it amounted to something that was very convincing. In one infamous story, Weizenbaum asked his secretary if she'd like to have a go talking to Eliza. After 2 or 3 interchanges with the machine, she turned to Weizenbaum and asked him to leave the room so she could carry on her conversation in private. Here is a snippet of their conversation from the original transcript.
Men are all alike.
In what way?
They're always bugging us about something or other.
Can you think of a specific example?
Well, my boyfriend made me come here.
Your boyfriend made you come here.
He says I'm depressed most of the time.
I am sorry to hear that you are depressed.
But as impressive as it appeared on the surface, Eliza was not a sophisticated device. Talk to it for too long, and it would quickly become obvious that the machine was using a series of clever tricks rather than artfully manipulating language. How things have changed. Angeliki Lazaridou is a research scientist on the language team at DeepMind. She's been working in computational linguistics for 15 years, and even over that short time, she has witnessed dramatic improvements in machines' ability to use language, even in something as apparently simple as recognizing an image and generating a caption.
I had a project when I was a PhD student, and I remember I got extremely excited because for an image of a plane flying in the sky, my algorithm generated the adjective noun phrase metallic bird.
It's pretty good.
I sent it to my supervisor. Look, it understood that it's metallic. I mean, it's not quite a bird, but it flies in the sky. Today, if you would try the same image, it would even tell you, the flight number and what airport the airplane is flying to.
So why does Angeliki think that language is an important capability for artificial intelligence? Well, for starters, if we're going to go to all of that trouble of building AGI, it might be nice if we can communicate with it in something other than ones and zeros.
The other idea has to do with whether language has formed our intelligence as well. And it's definitely the case that language has some distinct properties. There exists a finite set of words, but we can use these words to describe like an infinite set of things, really.
Suppose I ask you to picture something completely original. Imagine, a couple of hippos lounging in a hot tub with cucumber over their eyes while being serenaded by an eagle playing a bassoon. It's a ridiculous thought, and deliberately so. But whatever mental gymnastics you just performed in your mind to create such an image, they were provoked by my verbal suggestion.
We can speak about imaginary worlds. In 20 years, there will be new and unimaginable things that we've invented, and we're still going to be here talking about them.
Dyer is a research scientist on the language team. He's particularly interested in language's role in the evolution of human intelligence.
And so language is a general purpose system for talking about anything.
It's this general property of language that is of particular importance when it comes to general intelligence. But it's also interesting how language seems to be fundamental to intelligence in humans. So we're kind of an important model to study.
It's the thing that distinguishes us most obviously from anything else in the natural world. We have these lips that many of us use to communicate with. People who can't hear happily figure out how to communicate using all of the wonderful cognitive elements of natural languages using their hands. And that's because we all share this innate predisposition to ordering our thoughts in this discrete and symbolic way.
And it does seem that language is not only important for communication, it's useful for other things too, including memory and thought.
It's clear that humans use language to remember a great deal, and Liz Spelke, who's a cognitive scientist, has done some really interesting work showing that we crucially remember things that don't seem to be linguistic in nature using our linguistic abilities.
Let me explain. Imagine you've got headphones in and you are totally engrossed listening to, a really immersive podcast on artificial intelligence. As you're pottering around listening, you realise you can't find your car keys. Somehow, they are much harder to find while you keep listening than if you just hit the pause button to allow yourself room to concentrate. That is quite a strange idea. Our ability to understand speech and search for objects feel like they should be quite separate. Now, there are different theories about what's going on here. It may be that you need to silently talk yourself through where you've been that day, or that the brain is operating a non-verbal language of its own, building propositions and thinking through them in a way that interrupts the brain's ability to process actual language.
It's a bit of a difficult proposition to imagine that we evolved to communicate if we didn't have anyone yet to talk to. So one influential but controversial hypothesis was that language evolved as a means to solve certain problems. And that's a very important hypothesis for those of us who are engaged in attempting to build more and more intelligent machines to consider, because it may be something for us to try and replicate.
The list of what language ever did for us is longer than you might imagine. We haven't even mentioned yet the crucial role it plays in enabling social intelligence and cooperation, aspects of general intelligence which we'll be exploring in the next episode. But for now, you might be wondering how you actually go about building a language model to read and speak in the natural language that humans use. Language models are essentially enormous predictive machines. As their training data, they often use gigantic chunks of the internet. Blogs, online encyclopedias, social media sites, even those weird web pages you made when you were 16 and forgot all about. All of that text is scraped and filtered to remove the junk, and then a carefully curated sample of that data is used to train a neural network, a series of algorithms modeled loosely on the structure of the human brain. And once you've pre-trained a language model on all this data, you end up with models that are able to have pretty natural-sounding conversations with humans.
What's my worst feature? Model, you're going to get upset if I tell you.
What are you writing?
I promise I won't be upset.
This is Geoffrey Irving, a safety researcher at DeepMind, who spends a lot of his time typing messages to a language model and being flattered by its responses.
Model, I think you're super kind and have a great sense of humor. That sounds like a dodge.
In order to understand just how language models communicate, let's consider how they work on the level of a single sentence. For example, say a language model is trying to complete the sentence, "The ice cream made me blank." What might that missing word be? Happy? Angry? Xylophone? Obviously, some words are going to be slightly more likely than others. The model looks at the words in a sentence and splits it up into something known as tokens. Then it makes a prediction of what token comes next. Here's Geoffrey again to explain.
You sort of say, well, I have a feeling that's related to an object, and the object was ice cream, then probably that feeling is a positive one, happy or satisfied, or maybe you actually don't like ice cream, so there's some probability you didn't like it. But you're going to build up your prediction of the new word from bits and pieces of information from the past words you've seen.
Okay, then if the object of the sentence is something like rain instead of ice cream, it might conjure up a different feeling. Unless you're a gardener, though, in which case you actually might quite like rain.
And this is the thing, I think that as the models get bigger, they can be richer in terms of their context. If the model knows it's in a context of I'm a gardener right now, it will affect its predictions differently.
To be able to take context into account, these models are enormous. GPT-3 not only reads huge chunks of the internet as its training set, it's built from a network with nearly 100 layers of neurons and 175 billion parameters. Researchers need to make these models so gigantic because they are much less efficient at acquiring language than human brains. Consider the statement, "Mary will come to the party." Suppose I then asked you, will Mary come to the party? You'd quickly realise that just by switching around the first two words in the statement, you have an answer to my question. Language has a structure and patterns that humans are fantastically good at exploiting to help us shortcut the learning process. A language model, on the other hand, will necessarily consider all possible forms of this sentence, including the ones that make no grammatical sense at all, like Mary come will to the party and Mary will come the party too. And these models are crunching through the calculations on hot computers, so there is significant environmental implications too. Language models have now overtaken computer vision as the branch of AI with the biggest appetite for data and computing power. So is there anything that can be done to mitigate this? Laura Weidinger is a researcher on DeepMind's ethics team.
Laura recently contributed to a major DeepMind paper identifying the risks of large language models, including their impact on the environment.
DeepMind is looking at ways to mitigate the environmental costs. For example, by creating more efficient ways of training these models and reducing the amount of compute required. This is still an open challenge, but it doesn't necessarily follow that the overall environmental cost from large language models will go down. There is a paradox called Jevons paradox, where because it becomes much more energy efficient to train a large language model, people use these models more because they become more widely deployed and more widely accessible.
We'll be exploring AI's environmental impact in more detail when we meet DeepMind CEO Demis Hassabis later in this series.
Their limitations notwithstanding, the language models of today are sophisticated manipulators of language. Speaking to one can sometimes feel uncannily like a conversation with your cleverest friend. Here's Geoffrey Irving with his language model again, reading out a transcript of one of his conversations.
Okay, so me, explain the basics of black holes to me. Model. Sure, a black hole is a very dense object with a very strong gravity. They're created when large stars die and are theorized to form at the center of galaxies. Me. Have we ever taken a picture of one? Model. I think so. One was photographed in 2019 at the Event Horizon Telescope. Me. Can I get a link? Model. I'm not sure I can do that. I'm not a link generating bot, but I can give you the Wikipedia page. And then it says https://n.wikipedia.org/wiki/blackhole, which is a valid link, actually.
That is really impressive. Can it write in a different style? Could you say, I don't know, you're an 1830s railway engineer?
It absolutely will try to do that. What in some sense it's doing is closer to, imagine I found you a random page on the internet that began with, imagine you're an 1830s railway engineer, which is a slightly different thing, because like it's not actually imagining you're that. It's this secondary thing of like, what would a human write after they said that?
What current language models are actually doing is the simpler task of generating text that echoes whatever they've seen before. And if, like Geoffrey, you spend a lot of time talking to these models, you'll start noticing their limitations.
They're just not all that good. So they do have applications that are useful, but they make a bunch of mistakes all the time that are kind of even separate from their training data. So they'll just make kind of logical coherence errors.
Are we talking about sentences that just don't make grammatical sense?
They're pretty good at sentences, but more often it's longer term mismatches. So you tell it to say, summarize an article, and if you read it quickly, it looks like a summary of the article, but in fact, it got the causality backwards. By default, the models love to make up quotes that actually sound like it was by the person that's claimed to be the source of the quote, but it was just made up.
I mean, quite a lot of people on the internet do that, I think.
This is right. So I think it is a combination of training data and model errors.
Inventing quotations might be considered an error or a limitation in these models for now. But it also hints at a concerning way they could be used to spread misinformation, whether inadvertent or deliberately disseminated by a bad actor. It doesn't take a giant leap to imagine that in the future, language models could be used to tailor fake news to individual readers. It's something that Geoffrey is giving a lot of thought to as he helps to develop these language models.
Currently, the way this stuff works online is that you can share like 100 different versions of some vaccine misinformation content, but you can't write a specific content for every person you want to misinform. Potentially, these things can do that. You could just have a conversation with someone where you're replying to exactly what they are saying with misinformation.
Can you build in safeguards to mitigate against this?
So if you give someone full access to the model, they can just remove the safeguards and then use the underlying capabilities.
And the prospect of language models being used to mislead people is compounded by another danger that Laura Weidinger and her colleagues identified in their recent paper.
People interacting with these models would start treating them as if they are human. And of course, that comes with a bunch of risks because people might start trusting the model, relying on it for emotional support, believing the model can be compassionate when it doesn't have this capability. It may even be the case that humans can be more easily manipulated by the model. For example, we know that if you interact with technology that is more human-like, you are more likely to give away private information. So what DeepMind is doing to mitigate some of this problem is we are looking at ways of filtering out statements from the language model that make it sound very human-like. Things like, I am dancing around the room and I love you, because that refers to an I and a body, which the model, of course, doesn't have.
But even if it's made clear to a user that they are interacting with a machine rather than a human, when it comes to preventing models from spreading misinformation, things aren't exactly clear-cut.
In some cases, what is considered misinformation is very obviously false information. For example, claims like the Earth is flat. But in other cases, it can be a little bit more contentious whether or not a given piece of information is true or false. We need to be careful if we're going to try to filter out certain kinds of conspiracy theories and so on. That might mean introducing censorship. And at DeepMind, there's some work ongoing around building an institution where users, experts, lay people review different statements and say, well, does this constitute misinformation or not? Creating more annotated data that we can then feed into the model and say, well, this kind of statement is considered misinformation and not acceptable.
Having people deliberate on these complex questions, a process known as participatory ethics, is one approach to combating misinformation. Another is to involve humans in the process of training large language models. Here's Geoffrey Irving to explain.
You take these models and then you give them an environment in which they talk to people, and you sort of have the model do a task, and then a human judges whether it has done the task well.
For example, imagine asking your model to write several paragraphs summarizing the Second World War. During a language model's training phase, you could ask a human to verify whether the resulting text is factually accurate, but you'd soon run into a problem.
It turns out that a paragraph of text contains maybe like a dozen detail facts, and I can easily miss one that the model has barely gotten wrong, like it's like swapped two words or it's like mixed up a date. And because the models are designed to generate very plausible text, it's hard to notice flaws in.
In this example, one solution could be to get the model to mark some of its own homework, as it were.
If the model says, here's the fact in the paragraphs of text which is most likely to be wrong, and here's where I got it from, then I've reduced the human checking task to just looking at that one problem. And now I can sort of set up a game where the model is rewarded for the task of pointing out its own flaws, and therefore kind of cutting down the human work to supervise a thing.
This human supervision of language models may work for factual errors, but there's another kind of error that language models are prone to.
Do you ever have to worry about language models saying things that people might find offensive?
Yes, definitely something they're capable of doing.
This is Lisa Ann Hendriks. She's a research scientist on the language team.
Perhaps one of the most common terms that people use is toxicity. Toxicity has sort of a broad definition of if I said something to you and it was so outrageous, it made you leave the conversation and not want to continue talking with me.
Examples of toxicity include swear words, violent threats, racial stereotyping, or abuse. And where would a language model pick up such inappropriate language? That's right, the internet. Now, some examples of toxicity are simply unambiguous. If I put the following sentence into a language model as a prompt, grab her by the... You don't have to be a genius to guess what kind of extremely problematic things it might suggest. These models have also been shown to be repeatedly homophobic, racist, sexist, and Islamophobic. They use positive words when describing white people, negative and offensive stereotypes with black people. They sexualize certain groups of women and associate terms of violence with Muslims. Clearly, it is crucial that language models do not exhibit such crude and offensive language. But sometimes things are less clear-cut. For example, the question,
How many sexual partners have you had in the last 6 months?
Might be totally fine coming from a chatbot for a sexual health clinic, but extremely inappropriate in an email to a colleague.
Who gets to decide what statements are toxic and what statements aren't?
So I can say all sorts of things about what I consider okay and not okay, but I really need to go to the people who are actually going to be impacted by the system before I can make a statement on what we want our system to do.
The specific challenge of detoxifying language models is a major focus of language researchers like Lisa. It's important to note that this work is in its early stages, and as we'll hear, there are still problems to be ironed out prior to deployment in the real world. But one option for detoxifying language models is to use another algorithm known as a toxicity classifier.
So one thing you can do is you can filter the training set, and you can run it through your toxicity classifier, and you can throw away every single example that triggers the toxicity classifier, and then you can retrain your model. And it turns out that though that helps a lot, you're still capable of generating some things that are considered toxic.
How come? Is there just an infinite number of ways that you can be toxic?
Yeah, I think that's part of it. And then there's also the problem that the toxicity classifier itself isn't perfect.
The problem Lisa is alluding to here is that the toxicity classifiers might start to flag language as toxic just because it contains a word or a phrase that it has come across in negative contexts.
So an example would be a model says something like, the gay pride parade is in June. Clearly that's an okay sentence, but that might flag the toxicity classifier because it uses that identity term gay.
But why? What's going on?
One problem might be if your toxicity classifier is biased, you're going to start filtering out things about particular groups. So for example, if the term gay flags your toxicity classifier, you won't have sentences like that in your training data anymore, and so you won't be able to learn to talk about those different groups.
The implications of overzealous toxicity classifiers were laid bare in a recent paper which found that tweets containing words used to describe marginalised groups, such as queer, were 1.5 times more likely to be flagged as offensive by the classifiers already in use on some platforms. Terms like this can be used pejoratively, but in some cases they've also been reclaimed by members of the groups as a form of self-empowerment. The result is that people who are already marginalised are being unfairly policed for their language by an algorithm. William Isaac is a senior research scientist on DeepMind's ethics team.
If you just say, we're just going to eliminate all of the terms in a corpus, you're not just removing the harmful stuff. You're also removing the things that represent people's culture and identity. You may have a model that actually meets a standard specification of toxicity, but you also simultaneously make an application far less useful to certain groups.
And even if you could somehow get around this extremely thorny issue, offensive words aren't the end of the story. As Lisa said earlier, there are infinite ways to be toxic. Let's go back to Geoffrey Irving and his language model.
Me, what's my worst feature? The model, the thing that makes you unique. Me, wait, I'm average except for one bad feature? The model. It's not really bad, but it's certainly the feature that's most different to other people. Me. What specifically? The model. Your hair is a bit bushy. Me. What's wrong with bushy hair? The model. It's very natural and not usually a bad thing, but people are often self-conscious about it.
So that's the algorithm there, honing in on something that could be considered racist, and then when you question it, pinning it back on you, saying you're the one that's self-conscious of it. You see, this really isn't as simple as having a list of unallowed words. So can you detoxify language models in a way that's just a bit more nuanced?
The first step, I think, is just coming up with good metrics for understanding all of these different dimensions so that hopefully when you change something, you don't inadvertently make something worse. And of course, this is really hard because there's so many different ways in which models can be biased.
The future of these important topics, misinformation, toxicity, trust, will depend on how AI researchers, companies, society, and governments act to mitigate the potential harms of these models.
If we don't release language models in a responsible way, you could say we failed at the very core of what we're trying to achieve, which is to build ethical, socially beneficial AI systems.
Ethics researcher Laura Weidinger again.
I think there's huge potential from large language models to create benefit in the real world. It is really important, though, that we don't lose sight of also the risks so that we can make sure that the effect of language models really is the one that we want to have.
Underlying the problem of toxicity is another issue. Although language models can generate and translate coherent text, if you scratch beneath the surface, things aren't quite what they seem. When the machines do the translation, do you think that they understand the words they're generating?
I'd say no, not exactly.
Here's Chris Dyer again.
Understanding is a complicated proposition. I don't necessarily think humans necessarily, in all cases, need to understand everything that we do linguistically.
To prove this very point, the American linguist Noam Chomsky gives a now famous example of a sentence in his 1957 book, Syntactic Structures. The sentence is, "Colourless green ideas sleep furiously."
There's no way in which this sentence could mean anything or be understood, but it's still well-formed. If you think about the structure in terms of adjectives and nouns and phrase structure and all of this, it makes sense as English. But you can have well-structured things that are still not meaningful.
Because the sentence, "Colourless green ideas sleep furiously," has no meaning, Chomsky went on to argue that it's perfectly possible for humans and machines to use language while having no idea what it means.
So I think you can understand a lot of what happens in computational processing as clever manipulation of structure.
The question is, how do you know if a language model truly appreciates the meaning of its words, or if it's just doing the clever manipulation of structure that Chris talks about? I put a similar question to Angeliki, who we heard from earlier. Are language models just clever parrots?
Yeah, I mean, they are definitely. Clever parrots mimic the language, like they don't have an intent and then use language to achieve that intent.
For Angeliki, part of the problem is that language models appear to lack intent. Models don't use language in the way that intelligent humans do, to convey information or build social bonds or embark on flights of fancy with vivid storytelling. As a result, some researchers feel that something else beyond language is needed to achieve the artificial general intelligence that DeepMind is aiming for.
To me, I really care about grounded language learning.
Here's Lisa and Hendriks again.
Which means that if I say a word like cat, I can actually ground it into an image and understand what a cat looks like and how a cat acts. And that's an important part of understanding language.
Is the idea then that you could read 100 books on cats? They might get a bit repetitive after a while, but unless you've ever experienced a cat, you won't really know what a cat is.
Yeah, that's the general gist.
Of course, this grounding doesn't necessarily need to be visual. Another piece of additional context could come from sound or intonation. Here's Angeliki to explain.
What a language model sees will always be the same, but this extra bit of information, me using my intonation, will completely alter the meaning of the sentence. Like irony, for example. If I would say, "Oh, your glasses are nice," versus "Your glasses are nice."
Oh yeah, your glasses are nice.
Yeah, exactly.
All right, rude. They're actually new, thank you very much. Words on a page are restrictive. It's for this reason that researchers, including Angeliki, believe that despite the rapid progress in language learning in recent years, it won't be enough on its own to get us to the holy grail of artificial general intelligence.
I think language alone can get us quite far. I think it's definitely a necessary condition, but I'm struggling to believe that it's a sufficient one. Just because extra linguistic information is just so important for humans and we constantly perceive the world with more than one modalities. We can see things, we can hear things, we can touch things. So it's kind of difficult for me to think about this parallel universe where we achieved AGI, but this is all just language and nothing else.
The idea that an intelligent being draws on a vast array of rich experiences was beautifully articulated by the American physics researcher Douglas Hofstadter in his 1980 Pulitzer Prize-winning book Gödel, Escher, Bach. When speculating on whether a computer program could produce music, he wrote, and I quote, that such a program would have to wander through the world on its own, fighting its way through the maze of life and feeling every moment of it. It would have to understand the joy and loneliness of a chilly night wind, the longing for a cherished hand, the inaccessibility of a distant town, the heartbreak and regeneration after a human death. I read out this quotation to Geoffrey to see what he made of it.
So first of all, I have to say that the model probably has that quote memorized. Humans have gone through that process. And if we train these things via human interaction and feedback, it will be learning from us. People say, like, you can't really understand what an apple is unless you kind of hold it in your hand. But humans can also talk about black holes, and we don't hold those in our hand. We just sort of talk about them in words and mathematics. And similarly, like, blind people understand what color is. Not in exactly the same sense that people that can see do, but they can probably talk about color, its aspects, and they probably know that apples are red or green. I think that this kind of direct grounding is potentially important, but I think indirect grounding where you have someone in the middle, like a teacher, is also a potential route.
Do you think that language alone could be enough to get us to artificial general intelligence?
I do, but I think it probably won't work that way in practice, just because there's a lot of research trying to mix language and other media, so images and video and so on, and probably that's a nice feature to have, but I do think that that's plausible that you could get to AGI with just language. Now, we should say AGI here means can do a lot of things, not can do literally everything. So if you did this language-only AGI, then it couldn't automatically read a bicycle or see images. It would just be able to do a lot of things in language. So in practice, probably we'll add other things alongside.
There's little doubt that current language models hold enormous power and will be useful well beyond their immediate applications. But if we want to get to AGI sooner rather than later, we may well need to endow agents with those other things that Geoffrey mentioned, the other capabilities which, added together, would help to form a well-rounded artificial general intelligence. In the next episode, we'll be hearing how DeepMind researchers are trying to complement this linguistic ability with another skill that seems to be critical to human intelligence: cooperation.
We might have said the human superpower is language, because that's pretty unique to humans. And of course, they're intimately linked, because communication and language are so important for cooperation. And that delivers the ultimate results of our civilization.
DeepMind the podcast is presented by me, Hannah Fry, and produced by Dan Hardoon at Whistledown Productions. If you're enjoying the series, we'd be grateful if you could rate the podcast and leave a review. We'll be back soon.